All right, next we're going to move on to is solving exponential equations. And how we do this is we want to take the logarithm of both sides and then solve for x. So here's our first example. We're going to take the log of both sides. Then we can use our power property. We're going to take that 2x and bring it down in front. So the 2x goes down in front, and then everything else stays the same. Now what we want to do is we want to get the x by itself. So what we can do is we can divide both sides by 2 times log of 3, and then divide the other side by 2 and then log of 3. So what happens is the 2's cancel out, the logarithm of 3 cancels out. So now what we're left with is x equals logarithm of 27 divided by 2 times log of 3. Now we can go ahead and use our calculator to enter that in, and we get 1.5. All right, here's a second example. We take the log of both sides. Then we can go ahead and take that exponent and bring it down in front using our power property of logarithms. Then we want to get that x alone. So I'm going to first do is I'm going to divide both sides by the log of 4. And why we do that is to remove the log of 4 on the left. So now we're left with x minus 1 on the left side, and then our 2 logarithms on the right side. Then we want to go ahead and undo the minus 1, so we would do our inverse operation, so we would add 1 to both sides. And then we would enter this into our calculator, and we get x to be about 2.30. Here are some more examples. This time I'm going to do example A little different. I'm going to change this to an exponential of base 3. So 3 squared is 9. And then we still have that 8 minus x. And I'm going to change the 27 to the same base of 3. So 3 cubed is 27 raised to the x minus 3. Then I'm going to use my exponent rules. This is a power to a power, so we can multiply, and then power to a power we multiply. So that's 3, and then times 2 quantity 8 minus x equals 3 raised to 3x minus 3. So again, power to a power, you multiply those exponents. Now I'm just going to simplify these exponents. So I'm going to use my distributive property. So we get 2 times 8 is 16. 2 times negative x is negative 2x. And then I'm going to distribute again. 3 times x, 3x. 3 times negative 3, negative 9. Now notice that these exponentials are the same base. So then we can go ahead and use our one-to-one property, and we just focus on the exponents. We just set the exponents equal to each other. And then we solve them for x. So what I'm going to do is I'm going to subtract 3x from both sides. So 3x is gone on the right. And then I'm going to subtract 16 from both sides. And then combine my like terms. The left side we have negative 5x. The right side we have negative 25. Then we're going to divide both sides by negative 5. And then simplify. So negative 25 divided by negative 5 is 5. All right, our next example, we can't do the previous process because 7 to the first equals 7. 7 squared is 49. So we can't take that 21 and change it to the same base. So we're going to go ahead and take the log of both sides. Then we can use our power property. We bring that negative x down in front. Now we can go ahead and solve for x. So we're going to divide both sides by log of 7. So that's going to cancel out the log of 7's on the left. Then we want to get rid of that negative 1 on the left side. So what we can do is we can multiply both sides by negative 1. That's the same thing as dividing both sides by negative 1. So again, all we did is we took that negative that was out here, and we just divided it by negative 1. So these cancel out. Then what we would do is we'd enter this into our calculator. Be very careful. You would want to use a large bracket. And when we're done, our answer will be approximately negative 1.565. I do suggest that you pause and enter that into your calculator to make sure you know how to use it.